Good day, everyone. Welcome back to the channel. In this video, we will be continuing with Euclidean geometry, where we will be dissecting or talking about proportionality theorems. So, without wasting any further time, let's jump straight to the video. Okay, before we dive into the topic, I just want to quickly define what a ratio is. And in simple terms, a ratio is a relationship between two things. Okay, so a good example of that, let's say for example you're trying to make coffee, right? And when you're trying to make coffee in maybe like a 1 liter box, and for every 500 milliliters of water that you put in, you have to put in 1 teaspoon of coffee. Okay, so for every one, or actually not for every one, for every 500 milliliters of water, you need at least 1 teaspoon of coffee. Okay, and maybe like 4 teaspoons of sugar if you like sugar in your coffee. Okay, so all these things operate together. Okay, so in a sense, if maybe you were asked, let me give you a question, a good example. If you are not even asked, but a good representation of a ratio would be you saying, for every 1 teaspoon of sugar of coffee, I need 4 teaspoons of sugar. Okay, so that is a relationship between these two things. Okay, that can also be represented as a fraction, meaning 1/4. Okay, so that's what ratios is all about. So meaning that if maybe you were asked, if I was to put 2 teaspoons of coffee, how many spoons of sugar would I need? Okay, and that over there is the unknown, and you'd be able to use your initial values of 1 teaspoon of coffee to 4 teaspoons of sugar. So now what you do is just cross multiply, and you'd have x equal to 8. So you need 8 teaspoons of sugar. Okay, assume you like sugar that much, but the idea of ratio is just basically the relationship between two things. Okay, just the relationship between two things, and that can be represented in forms of ratios or fraction form. Okay, as I said, 2/8 in this case can also be simplified to 1/4. Okay, so it doesn't mean that 2 teaspoons of sugar are equal to, 2 teaspoons of coffee are equal to 1 teaspoon of coffee. It just means that the proportion between the amount of coffee you put over the amount of sugar is the same throughout, in a sense. It doesn't mean that 8 is equal to 4. No. 8 is not equal to 4, we know that. But the ratio in which the relationship between the coffee and the sugar is the same throughout, meaning that if I need to put 3 teaspoons of coffee, then I'm going to have 12 teaspoons of sugar, which is still equal to 1/4. Okay, so it's just the relationship between two things in hindsight, or in simple terms. That's what a ratio is. So now that we've defined what ratio is and we've shown an example of how we can use it, let's dive into the proportion theorems. Okay, another example of a question or the idea of proportionality or ratios is, let's say we're given 2 lines. We're given line A, B, C, and D, E, F. Okay, so we know that from A, B, the ratio between AB is to BC would be equal to 6:4. Okay, and if we were to simplify that, we'd get 3:2. Okay, Obviously, to simplify that, we need to divide by the common factor of 2. And if we divide 6 by 2 and 4 by 2, we get 3 and 2 respectively. Okay, and the ratio of line DEF, or DE is 2, EF would be in this case 9 is to 6, and if we simplify that, we'd get 3 is to 2. Okay, so if you look, the ratio of AB is to BC is equal to 3 is to 2, and the same as the ratio of DE and EF, it's equal to 3 is to 2. Okay, we can see visually and from what we're given that these two lines are not equal in length by any means, but their ratios, the relationship between AB and BC is the same as DE to EF. Okay, so that's the concept of ratio explained in the most simplest way. It's all about ratio. It has nothing to do with the lines being equal, but we're saying the relationship between two things is the same, or keeps the same ratio throughout. And in this case, AB is to BC keeps the same ratio as DE is to EF, although we know very well that AB is not equal to DE, nor BC is equal to EF. Okay, we know that that's not the case, but the ratios are the same. So, and that's the idea of proportionality. Okay, and as I've already mentioned, we need to jump straight into the theorems. I just wanted to give you one more example before we do that, but let's now quickly dive into the theorems and how we can apply this knowledge of ratios into solving more complex problems. So, the first theorem of proportionality says a line drawn parallel to one side of a triangle that intersects the other two sides will divide the other two sides proportionally. Okay, so now let's try to draw what that means, or to visualize that and see an example of how that is, or how that applies. Okay, so let's say we're given a triangle here, DEF. Okay, and then we draw a line which is line CB, and we also declare that this line CB is parallel to line EF. What that means is that the ratio, which is DE, sorry, not DE, DC, the ratio of DC is to CE will be equal to the ratio of DB is to BF. Okay, and that is obviously because of the proportional, or the first theorem of proportionality. Okay, so what we're basically saying is that the ratio of DC, which is obviously this part, over this part here, will be equal to the ratio of DB, which is this part, over BF, which is obviously that part over there. Okay, so now we're going to try to do an example to see how that can be, or we're just trying to try to put numbers to see how that is true. So if we plug in numbers in definition, now we have DC is equal to 4, we have CE equal to 6, and we have DB equal to 6, and BF equals to 9. Okay, and if we plug in the numbers in this case, obviously DC is equal to 4 and CE is equal to 6, and we're basically saying that we'll have the same proportion, or the same ratio as DB, which is 6, over BF, which is 9. Okay, and obviously if we simplify 4 over 6, we'll have 2 over 3, as well if we simplify 6 over 9, we'll have 2 over 3. Okay, so that stands. It means that this triangle here has the same proportion, and that's because this line CB is parallel to EF. Okay, and another thing that we can see is that CB over EF is equal to 10 over 15. And if we simplify that, we'll have 2 over 3. Okay, which is basically the same as this one over here. Okay, so now we can integrate, or we can conclude that with this proportion theorem, CB, which is obviously the line parallel to EF, will also have the same ratio as the other sides. CB over EF will also have the same ratios as the other sides. So it's not just those two, which is DC over CE and DB over BF, that have the same ratio, as well as the two parallel lines, or the lines that are parallel to each other, will have the same ratio as the rest of the other lines, basically, or the rest of the other sides. Okay, so that is theorem 1 of proportionality, basically. And to go back to it, it says that a line drawn parallel to one side of a triangle that intersects the other two sides will divide the other two sides proportionally. It will divide them proportionally. Okay, and the converse of that theorem basically states that if a line divides two sides of a triangle proportionally, then that line is parallel to the third side. So now just imagine we're not told that that those two lines are parallel to each other. We're not told that the two lines are parallel to each other, but we're given all these figures to conclude that they have the same ratio. Okay, so now from concluding that they do have the same ratio, we can also conclude that CB is parallel to EF. Okay, and that is what the converse of theorem 1 of proportionality basically states. It states that if we have proven or concluded that the lines, or the three lines, are proportional to each other, then the line that cuts this triangle from these two sides will be parallel to EF, and in this case it's this line over here. Okay. So that is it for this video. I really don't want to make the videos long. I'm going to divide the videos into numerous videos, or I'm going to divide this chapter into numerous videos so that you guys can kind of dissect it one by one. Okay, and for theorem 1, I think this whole video will basically explain everything that you need to know about theorem 1. Obviously there isn't any examples that are complex, but hopefully the basic information that you got from this video will help you tackle theorem 1 questions of proportionality. Okay, so that is it for this video. Please don't forget to like, share, and subscribe. Okay, and also don't forget to join our weekend sessions every Saturday at 10 a.m. This is meant for grade 12 students. The lesson is completely free. It's 1 hour and 30 minutes, and we'll be dissecting information based on the videos that will be released for that week. And obviously for this video, or for this weekend, we'll be dissecting proportionality theorems in depth. Okay, so cheers guys. I'll see you in the next video.